In the previous videos, we have explained subsetting with respect to vectors. In this video, we will try to explain subsetting with respect to matrices. That is, how to access elements of matrices. Also, how to change the elements of matrices or submatrices. So, this is the essence of subsetting, which is discussed in this video. We know that by typing the matrix name at the command prompt, we will get whole matrix as the results. To achieve this, we can do either of the following. That is, X, here X is the matrix, X square brackets inside comma also gives me the whole matrix. And the matrix here is a 4 by 5 matrix. So I can even specify X inside the square brackets 1:4 comma 1:5. This also gives me whole X. We have functions like n row, n column, which takes matrix name as argument and returns number of rows or number of columns of the matrix. We can also use this to get whole matrix data. That is, X square brackets 1 column n row of X comma 1 column n column of X and closing square brackets. This gives me the whole X data. That is, here X is the matrix. Of course, the good old programming style, if I wanted third row, fourth column element value, we can simply say X square brackets 3 comma 4 closing square brackets gives me third row, fourth column element of a matrix. This is a established fact, so we did not give emphasis for that. We can access a specific row or a specific column of a matrix. For example, if I wanted to access first column, then X square brackets comma 1 square brackets close. Maybe if I wanted first row of the matrix X, simply X starting square brackets 1 comma closing square brackets. This gives me first row of the matrix X. In place of 1, you can use 2, 3 or any row number or column number. Like this, we can access a specified row or a specified column. Do remember, this specified row or specified column is returned like a vector. In order to check that the returned value is a vector or not, we have used isMatrix, isVector functions. That is, whatever X square brackets 1 comma closing bracket returns, that is sent to functions like isMatrix and isVector. You may find on the screen that the result is true with the isVector, whereas it is false with isMatrix. This supports our argument or our statement that if we access either a row or a column, the result is a vector. Of course, we wanted to cross check X square brackets comma square brackets close. What it is going to give us? Whole matrix. We wanted to cross check this also. Thus, whatever it returns, we have sent to isVector, isMatrix. This gave me true with isMatrix function only. That means it is returning the result as a matrix. Like this, we can use isMatrix, isVector functions to cross-check what it is giving. We can also select a group of rows or a group of columns of a matrix. For example, in this slide, we are selecting second row, third row of the whole matrix X. That is X square brackets 2 colon 3 comma closing square brackets gives me second and third rows of the matrix X. The same thing X square brackets comma 2 colon 3 closing square brackets gives me second and third columns of the matrix X. Like this, we can select a group of rows or a group of columns or consecutive rows, consecutive columns of a matrix also using this subsetting concept. isMatrix function is used to confirm that these commands are returning submatrices. Rather, they return matrices as the result. We can use negative indexes also. For example, X inside the square brackets minus 2 comma. What it does? It gives us the rows other than second row. That is, minus 2 means we are referring to all the rows other than second row. Similarly, X inside the square brackets comma minus 2 refers to all the columns of the matrix X other than second row. Like this, we can use negative indexes also in subsetting. We can also select a group of rows or a group of columns which are not necessarily consecutive things. And also, if we wanted, we can select a row more than once, that is repeatedly, or a column repeatedly also. For example, here X inside the square brackets a vector C 1, 3, 1 is used, which indicates that we wanted first row, third row and again first row is acceptable. Same is applicable for column selection also. Like this, while selecting the rows or columns, the rows may not be necessarily consecutive, may not be required to be coming only once, they can be used more than once also. And also remember the result. So the vector is C 1, 3, 1. So which means that the result contains first row first, then third row as the second row, again first row of X as the third row. Like this, the order is maintained. This is applicable for columns also. Similar to vectors, here also the vector which specifies the required rows or columns, it should contain all positives or all negatives. Otherwise, we'll get an error. Let us select a little trickier problem. x inside the square brackets 2 column 4 comma 3 is to 5. It selects second, third, fourth rows of the matrix X. In each row it selects third, fourth, fifth columns. That is, the result is a 3 by 3 matrix. From this 3 by 3 matrix, for this 3 by 3 matrix, we are applying subsetting. That is, square brackets 2 column 3 comma 2 column 3 means from this 3 by 3 matrix we wanted to select a submatrix of size 2 by 2. You may verify on the screen that the result is a 2 by 2. Here, for this 2 by 2 matrix, we are accessing second row, second column element, that is 20. Like this, we can write complex subsetting equations according to our wish. Let us understand this equation. X is a 4 by 5 matrix as usual in our discussion. Now X 2 column 4, 3 column 5 gives me a 3 by 3 matrix. Then for that we are applying minus 2 comma minus 2, which indicates that we are asking in this 3 by 3 matrix we wanted other than second row, other than second column. Thus it gives me a result as 2 by 2, which are nothing but first and third rows of 3 by 3 matrix and first and third column elements of the 3 by 3 matrix. Like this, we can have complex expressions involving subsetting. Like vectors, with matrices also we can access elements using their row names or column names. That is, we can use strings as the row indexes or column indexes. The function dim names, when we apply to a matrix, it displays what are the column names, row names available. However, for our matrix X, as of now, there are no row names, column names. Thus, we are first creating some row names, column names using row names function and also column names function. This slide demonstrates that we can access the rows or columns of a matrix or a group of rows, group of columns of a matrix using row names and column names. For example, X of third comma, that is third is in between double quotes. Third is the name of the third row of our matrix X. So simply it selects the third row of X. Like this, we can select a group of rows or a group of columns of the matrix X using the names. Here we are selecting first and fourth row elements that belongs to fifth and second columns of X. The result is a 2 by 2. For that we are applying 1 comma 2. So that is a 2 by 2 matrix, and from that we are asking first row second column element. Here we are getting 5 as the result. that is as accepted. With subsetting using row names or column names, we cannot use minus style. This slide demonstrates this. This slide demonstrates that we can specify sequences for both rows and columns combinedly, and also they can be of same, that is positive type, or they can be negative type, and some of them, that is or maybe the rows can be positives and columns can be negatives also. This slide demonstrates that we can use an object vector which contains the row numbers which we wanted to select. That is, we can use a vector type of object also during subsetting. This slide supports how to change a submatrix of a matrix. Let us assume that I wanted to change the elements of second row, third row that belongs to third and fourth columns, that is a 2 by 2 matrix. I wanted to change all of them to 5. This can be achieved using this command. That is, we can change a submatrix of a matrix. This command also is in support of our statement how to change submatrix of a matrix. So I wanted a small 2 by 2 matrix with some values, with values 1, 7, 8, 2. Simply we can assign them. We can change like this a submatrix of a matrix according to our wish. This slide explains how to change a submatrix using a vector whose size is exact multiple of number of elements of the submatrix. Here the 2 by 2 matrix I wanted to change. The right hand side I have specified a vector with elements 1, 2. So what is happening? The submatrix 2 by 2 is getting filled with 1, 2. That means this vector 1, 2 is recycled. This is how assignment takes place. This is to support that the size, the right hand side, which we wanted to use to change the submatrix elements, the number of elements right hand side should be exact multiple. Otherwise we get error message. This is also in support of our statement that the values which we wanted to replace or assign, their number should be matching with the submatrix size. Otherwise we get into error problem. While subsetting, because of repeated columns and rows which we select, the resultant matrix can be bigger than the original matrix. This slide is in support of this statement. Here only first column elements are selected. because in this vector all the numbers 2, 3, 4, 5 are there. Only the number 1 is not there. Our matrix X is a 4 by 5 matrix. That is, first column is not there in this list. Thus, only that column will be displayed. This slide supports how to transpose a submatrix in situ. Means in the same memory we are getting the transpose of the matrix, submatrix. This type of operations are possible through subsetting. We can use as vector function to convert a matrix elements into a vector. Sometimes we may require this type of freedom also. In this video, we have explained how to access elements of the matrix. Various styles we have explained. Also, we have explained how to change the elements of a matrix. That is, submatrix elements can be changed or transposed. Maybe some operation can be on them carried out. Hope you have enjoyed the concepts. If you like, I request you to recommend to your friends to subscribe to my YouTube channel. Thank you.